Okay guys, it's me, Mrs. Carbajal. This is for my 5th and 6th period class that I answer some questions. If you could see, I went through all the material about what factors affect solubility. You have to remember PST, okay? That will help you understand what affects solubility, and that's going to be your pressure, your solvents, what type of solvent it is, and the temperature. Remember, temperature, when you add heat to something, it's going to make the particles move faster. Okay, so let's go through the answers. First here is your solubility table. It's another property, a physical property that you need to know about. It's kind of like density. You could identify a substance if you know its solubility in a certain temperature per 100 grams. Okay. Let's go through some of the answers. All right. So the next page, we were talking about polar versus non-polar. Okay. I highlighted some things here that I think you guys need to highlight. Please be aware that oil and water separate because water is a polar compound and oil is non-polar. So they're separating. I don't want you just to think of this every time you see this as density. They're talking about polar and non-polar. They're talking about solubility. Okay. Non-polar compounds do not dissolve in very polar solvents. Okay. But if it's another non-polar, they're going to dissolve. Okay. Pressure affects the solubility of a solution. Okay, so let's look at this one. All right, so they give you, this is a challenge question. This is going to be like a level 5 question. Determine which of these liquids are polar and which are non-polar by the way they form layers or mix together. The first answer is given. So it tells you that letter A, here it is here, is polar. Okay. If it's another polar, it's going to dissolve together. All right, it's going to make a color. So we're going to say anything that is mixed together or blended with the letter A has to be polar, just like the letter A. So that's why D is polar. Okay? Now we're going to look at this one, and you have B and E. They don't mix with the A. That's why they are non-polar. If you know B and E are non-polar, we're going to look at our letter F. If B and E are non-polar, then F has to be polar because it's not mixed together. It's kind of like a puzzle. So I wrote on up here, I wrote dissolving each other, and when it's here, if the non-polar, I wrote doesn't dissolve in very polar solvent. That's the level 5 questions. If you go over stuff like this, you read through it again, it'll help you. Okay, now we're going to the next page. All right, the next page, they're asking about how many grams of sugar could be in 50 grams of crystallized honey. Crystallized. That means it's super saturated. It's past its saturation point, and that's what's making it crystallize. All right, so we're going to take the 70%, change it to 0.70, and just multiply it by the 50 to get 35 grams. Okay, how would you explain why certain types of honey rarely crystallize? Easy, they are not super saturated. Okay, is there a way to turn crystallized honey back into liquid honey? You heat up the honey. Recall, particles move faster when heat is added, then solid turns into a liquid. All right, now I'm at the page that everybody gave up on. All right, the first question asks you about quick cooking, and it's talking about adding a handful of salt to the pot of water to raise the boiling point. Okay, this is what you have to remember. Explain whether the chef's plan to cook the pasta faster will work or not. It's not going to work. Here's why. It will boil at a higher temperature with the solute added, but you have to remember the amount of salt is not enough to cook your pasta faster. It was only a handful. I wrote over here, you have to recall that solute raises the boiling point. Solute, that's your crystals. Solvent, remember, are usually your liquids. the ones that do the dissolving. A customer orders some sparkling water. Sparkling water means bubbles. That's your gas. Okay. A customer orders sparkling water to drink, which is a combination of carbon dioxide and water, H2O. Determine which part of that drink are mixtures and which are your pure substances. Okay, so here's what I wrote. Sparkling means bubbles. And then I wrote over here carbon dioxide and H2O. Carbon dioxide is your gas, H2O is your liquid. They're not chemically bonded. Remember, it'll turn flat when that air escapes. The pure substance are made of the elements that are chemically combined. Okay? So remember, you're opening up that can of soda or your bubbling water, the gas is going to escape. Alright? Let's mix it up. Here we have mix it up. Remember, oil is nonpolar and vinegar is polar, so they're not going to mix together. We just did that a few moments ago. The pepper is a suspension. That's something I taught to you guys last week. You watched a video on it. You're supposed to take notes. Suspension means the particles are larger. Alright, sweet. Let's go here. So here you had to go back to the first table I told you about. Okay? And all you have to do is go 30 times 30 times the, hold on guys, 30, so we're going to go back to figure 1. Figure 1 says you're going to go here, it's at 100 grams, it's got 204. So coming back to that section, all you do is go 3,000 divided by 100 gives you your 30. You go 30 times the 204 and that'll give you the 6,120. Last one. It says, how can you tell when a solution is saturated? If it's saturated, that means there's too much. And it says you cannot dissolve any more of the solute. Kind of like keeping adding sugar to the tea. You can't dissolve anymore because there's so much sugar on the bottom. The only way you can dissolve it anymore is by adding heat. Okay. Next question, control variables. You are given 2 white powdery substances. How would you use solubility to identify them? One can dissolve in water, salt or sugar, as an example. Another thing is you cannot dissolve powder. So this property is similar to density. And then the last one asks you, what determines the properties of mixtures and pure substances? Mixtures, remember, you can physically separate through chemical means, filtration, magnetism, etc. Pure substances, remember, they all look the same throughout. It says the chemical combination of atoms determine the properties of a pure substance. When they're chemically combined, remember, they're combined at their valence electrons. Mixtures are not chemically combined, and you can use physical properties to separate them. Okay, guys? Have a good night. Review your notes. Thank you.